So this is lesson 1.3b, and we're still working with trigonometric functions and trigonometry. And if you remember, when we have a triangle, and if this is h, and we know a length of here and a length of here, in fact, let's not even call that h, let's call it c. The length of the longest triangle is usually called c. Do you remember this formula? Yes, you do. It's the Pythagorean theorem. And in order to find that, if we took the square root of this and the square root of this side, we would get the square root of a squared plus b squared equals square root of c squared is just c. Okay? So that's your simple algebra there from a long time ago. But what are we calling our hypotenuse now in trig? We're calling it r, because it's radius. So instead of calling that c, we're going to call it r. So that means you can find the radius of a circle or the hypotenuse or the longest side of a triangle using this formula right there. So let's give that a shot as we look at example number 1. Okay, so look at the graph here I have, and let's look at what it says for example 1. The terminal side of an angle theta. So here's my angle theta. The terminal side, remember from the last section, is we always start here and we go up this way, so this would be the terminal side. So the distance between these two is, we're calling it theta, and standard position passes through the point 815. So this point right here is 815. We went over 8 and up 15. Find the values of the 6 trigonometric functions of angle theta. All right. So if this is 815, we started here and we came over 8 and up 15. So the length of this is 8, the length of this is 15. Okay? So now what we need to do is we need to find the radius here. Well, how do we do that? Well, I just showed you. It was a squared plus b squared, or 8 length of one side squared plus the length of the other side squared. And because you're so smart, you know that 8 squared is 64 and 15 squared is 225. You add those things together and you get r equals the square root of 289, which is 17. So I know that my r over here is no longer r, but it's a length of 17. Okay, so that's good that we found those, because we need all 3 of those in order to find the 6 trig functions. So at this point, let's see, let's start with sine. Sine of theta, and the reason I call it theta is because it's called theta here. Sine of theta equals, what did we say that was? Y over r. Y over r, 15 over 17. Cosine of theta is x over r, or 8 over 17. Tangent of theta is going to be y over x, which in this case is 15 over 8. Got the hang of it? Go ahead and do cosecant, secant, and cotangent based on the formula that you have there. So for example 2, it says the terminal side of an angle theta in standard position. Remember, when it says standard position, it means the initial ray here is on the positive side of the x-axis. The terminal side, which is where the angle ends, passes through the point -3, -4. So we know we're going to graph -3, -4, and we're going to draw a line from the origin down here. It's always going to be from the origin down through -3, 4. So this is the angle that we're dealing with. That is theta. Find the values of the 6 trigonometric functions of angle theta. Alright, one of the things that I want you to learn, I need you to learn this real quick, and again, there's tons and tons of stuff to learn in trig, because this is all brand new stuff, you really don't have anything to base it on, is anytime you can, you're going to draw a triangle. Notice this triangle has a 90-degree angle right there. If I had an angle here and I was looking at this point, I would draw a line perpendicular to the x-axis here. And that would be the triangle I'm dealing with. Trigonometry deals with triangles. If I had a point that was clear over here, I would draw a triangle that looks like that. Notice my 90-degree angle of every single one of these triangles is on the x-axis. It will always, always be on the x-axis. Don't put it anywhere else. You will draw weird, crazy triangles that don't make any sense if you don't do it this way. So, what we're doing here is we're looking at, and your calculator compensates for this. You can find the tangent of a 187-degree angle without any problem, but back in the olden days they couldn't do that, so they had to make some changes here, and I'm trying to teach you how to do that a little bit. So what you've got, it doesn't matter which quadrant 1, 2, 3, or 4 you're dealing with, if you have a line and you're trying to make a triangle so that you can figure out the trig functions, because you have to have a triangle, they're going to be looking like that, and this line segment will always, the one that attaches itself to the x-axis will always have the right angle in it. So if you have a triangle that doesn't have a right angle in it, you did something wrong. Sometimes I get students that will draw their triangle like this. Okay? There's no right angle there. So it's wrong. It has to be this way so that you have the right angle there. Alright, so I hope that's not too confusing when you're drawing these triangles. But notice what happened here in this problem that they gave you. They drew theta here, but we need an angle that is less than 90 degrees. So that's why they took this one and they drew this triangle there. So that's what we're going to be focusing on right now, is that triangle. There we go. All right, so it says the terminal side is -3, 4. So we drew a line from the origin through -3, 4. My x is -3, my y is -4. If I wanted to find my r value, my radius right there, I'm going to do r equals the square root of x plus y. So r equals the square root of 9 plus 16. So r equals the square root of 25, and the square root of 25 is 5. So that's where that number came from right there. So again, I had to do that with every one of my triangles. I have to find all 3 lengths. I have to know this one, and this one. So let's look at the sign. Sine of theta is going to be -4 over 5. It's going to be y over r. And then if we want to find the cosine of theta, that's going to be -3 over 5. It's going to be x over r. And if I want to find the tangent of theta, I would, do my opposite over adjacent, or my y over x, which is going to be -4 over -3, which is going to be 4 over 3, because 2 negatives make a positive. So notice that I'm not really making theta a triangle. I'm making the triangle out of this one over here with the x-axis. That's where I'm making the triangle, is right there. I'm not even using all of this space up here because it doesn't matter, because it's 180 degrees and it doesn't work for trig. I mean, it doesn't matter. It's 180 degrees isn't going to change anything. So we're just looking at that triangle in that third quadrant. We're not looking for the other stuff anywhere else because it would give you the same thing. If you took your calculator, let's say, and you found the sine of this angle, let's do it in red, from here all the way over to here, that will be the same as the sine of this angle right there. So let's say, for instance, this angle is 180, let's say it's 225 degrees. So if you took the sine of 225 degrees, that should be the same as the sine of this angle, which would be 225 minus 180, because we're going to take this away from it in order to get this. So that would be, what, 45 degrees. So the sine of 225, which would be this length from here all the way over to there, should be the sine of 45 degrees, which is from here to here. So they should be the same. So your calculator you could put in as sine of 225 or the sine of 45 and still get the same number. Except one would probably be positive and the other one would be negative, and that's where we run into a little bit of discrepancy with the calculator. It kind of gets to be a problem. But anyway, let's continue on here, and we'll call this next video 1.3b.